Okay, now let's talk about the vertical line test. A curve in the coordinate plane is the graph of a function if and only if the vertical line intersects the curve more than once. So keep in mind what the vertical line test does for us. It puts a vertical line on a graph to check if it is a function. So I'm going to make a vertical line here. I'm going to check if that vertical line, again from the definition, a curve in the coordinate plane is the graph of a function if and only if a vertical line intersects a curve more than once. It is not a function. It is not a function if it crosses the graph more than once. So if I take this vertical line, I'm going to check example 3a. As you notice, I have this ellipse, if you want to call it. You can see I crossed the graph at more than one place in the coordinate plane. So therefore, a is not a function. I can say not a function. A lot of times they'll say, why is it not a function? It does not pass vertical line test. Or you could say something as for one x value, there are more than one solutions for it. Like here's x, there's a y answer there, and there's a y answer there. Okay, let's try question B. Does it pass the vertical line test? It's hitting the graph in one place, everywhere, everywhere, everywhere on that green graph. Therefore, yes, this is a function. Yes. And what could you say? Passes vertical line test. Simple as that. I know we learned this in Algebra 2, just a little recap of it. So, does the equation define y as a function of x? If it is a function of x, it should pass the vertical line test. Or for every x value, there should be one unique y value, not two y values. Let's do example 4. We can do this by solving for y. If I subtract x squared on both sides, negative y equals negative x squared plus 5, and then divide everything by negative 1, y equals x squared minus 5. So I've solved it for y. Now the question, is it a function, does the equation define y as a function of x? It does, because no matter what x value I plug in, I will only get one y value. All right, we can graph this. This is a parabola. You guys know this graph. It's x squared. The vertex would be 0, negative 5, 3, 4, 5. So point there, and it would be a parabola that opens up. And if we put the vertical line test to it, you'll notice that, can't get this line straight, but you'll notice that this line, first of all, I'm going to delete it because. So I have my vertical line. If I run it across that parabola, you notice it only hits in one place everywhere. So yes, it passed the vertical line test. So does the equation y define y as a function of x? The answer is yes. So let's look at the second example. And I'll make this clear after I solve for y. Add x to both sides. Y squared equals x plus 3. And now, you know what I'm going to do to solve for y. I'm going to take the square root plus or minus, that's key. So y equals plus or minus the square root of x plus 3. Now, if I graph this, it would look something like this. It's actually the inverse of the parabola. It would look something like this. Left 3. It would look something like this. Now, obviously, you can see it would not pass the vertical line test, so therefore it's not a function. But I can also see that no matter what x value I plug in, here, I would add 3, take the square root, and then I'd have two answers, one being positive, one being negative. So I plug in one x value, but I could get two different y values, therefore it's not a function. So for this one, we would say no. No. Y is not, so the equation does not define y as a function of x. Okay, so here I'm going to continue on. Here's some other things. Here's some standard functions, linear functions in the form of f of x. F of x equals b. That'll just be a horizontal line at the y-intercept. F of x equals mx plus b. You guys are used to that. You're seeing that. Here's some power functions. X to the second power, x to the third power, x to the fourth, and x to the fifth. We call those power functions when we have this here, x to the power of some number. Those are all called power functions. Here's root functions. If we have a square root, cube root, or fifth root, cube root, fourth root, or fifth root, those are called root functions. Reciprocal functions. Reciprocal functions are rational functions, like or I call them fractional functions. 1 over x or 1 over x squared are the reciprocal functions. Absolute value functions. F of x equals the absolute value of x. All right, basically the distance from 0. Just a bunch of different types of functions. Now, let's get into talking about using your calculator and how to graph. All right, so what I want you guys to do is take out your calculators, your TI-84 or your 89, and what you'll do is you'll go into the calculator. Here are the instructions over here. Obviously, I won't be able to show you how to do it, but you're going to go to the TI-84 and you're going to look for the y equals. And we can practice this more in class with me or Ms. Zara. Going to the y equals and then plug in this function f of x equals 2x minus 1. Where do you find the variable for x? You can find this little button on the calculator. Just look for it. Or on the TI-89, look for that. And then how do you graph? There's a button up, I think is, well, I know it's at the top, and it says graph. Again, I can show you in class, but you should be able to figure that out or find it right now. If you're using the 89, I don't necessarily use the 89 very often. You look for F3 and push graph. And then when you graph it, you should get a straight line. All right, so when you graph, we all know that 2x minus 1 is a linear equation. The y-intercept being -1 up to right 1. So it looks something like this. Domain would be -infinity to infinity, and the range also -infinity to infinity. So just practicing with some calculator procedures. All right, let's go to the next one. The next one should be absolute value. There it is. F of x equals the absolute value of x plus 3. Where's the absolute value on my calculator? All right, so in your calculator, you're going to look for math. Again, I can show you where math is. It's on the left side of your calculator, 3 buttons down to the 84. All right, I actually have a poster in the classroom. I can look at this right now. Once you hit math, you'll hit NUM, num, and then you push the button that says ABS, which represents absolute value. And then you put in x plus 3. All right, domain and range. Well, if we look at this graph, after you hit the graph, then you go through and do everything else like you just did before. Go to so you went to your y equals, and you'll enter in that equation, then hit graph. All right, but this is a graph that looks like this. Should be to the left 3, 1, 2, 3, and it looks something like this. If I talk about the domain, that's everything, -infinity to infinity. And the range is from here on up. So from 0 to infinity. It includes 0, so I'm going to put a bracket on that, a parenthesis, a bracket. Okay, let's take a look at another one. Here's a quadratic, and so now we want to put this into the y equals so we can look at the graph. Put this into your y equals, and then we'll be able to figure out a few things how to find the vertex. So in these other ones, we were finding a few other things as far as how to graph in general, and then how to find the absolute value. But on this quadratic, we'll figure out how to find the minimum or the vertex. So let me just kind of draw a little sketch of this one. It's a parabola. Don't know exactly what it looks like, but if I were to just go ahead and throw it in there, the y-intercept would be -1. It's probably going to look something like this here. just a parabola. And if I go to calculate, so now I'm going to look for the button that says calculate on the calculator. And when I see C-A-L-C, calculate, I want to go to, it's at the top, up above trace. So you have to hit second, calculate, and then you'll hit minimum. So I'm looking right here, minimum. Then just say left bound. So then you want to go ahead and put a left bound. So there'd be a little cursor. We know the minimum is right there. So just go to the cursor and put it to the left of that point. Then it says right bound and then push enter. Then once right bound, go to the right of that point, push enter. Now I know I'm on the left side and the right side of that minimum. All right. Then it says, do you want me to guess it? They put that little question mark there. Do you want me to guess it? And you say yes, push enter again. And then what it will do is it will give you the X and Y value of that parabola. It'll give you the vertex of that parabola. This right here. So I went ahead and found the completed smartboard of this one. And there is the graph of that parabola. All right, you can see there's the graph of it. And it looks like after it guessed it, it looks like it will get the vertex at -1, -2. So the vertex right here is at -1, -2. So what's the domain? The domain's still going to be -infinity to infinity. That's still fine. But the range, we want to talk about this Y value on up. So the Y value looks like it's -2, and it includes that all the way through infinity. Sorry about the smartboard. Sometimes it just doesn't line up perfect. Should be a 2 though. It's a 2, I promise. Okay? -2 to infinity. Like that. There you go. All right. I'm going to take a look at one more example. Looks like this here. Where it is the square root equation of x minus, or 9 minus x squared. And I have it on here. I'm going to erase some of this stuff so you can see it. All right, so there's the equation of it, or the graph of it, and you can see I kind of have some other markings on there, but it basically looks like this in blue, or it's in red. It's in two different graphs. But again, I put that in the calculator, and you can see now my domain goes from -3 to 3, including those numbers. All right, that's why it's in brackets. And then it's from here on up, so up to 3. If you look at the red one, it's actually a little bit better. 0, 3. So a bracket around 0, bracket on 3, 0 to 3. A few more things I just wanted to clear up with you guys. I want to clear up about some transformations. These are translations. If you have anything outside of a parenthesis, that is a vertical shift. So plus C will be an upshift of an amount of whatever. So if C is 2, that would shift the graph up 2. And minus C is a shift vertically down, if you want to say. All right, it would shift your graph down. We did learn some of this in Algebra 2. But when that shift is inside the parenthesis, it's a horizontal shift and opposite. So plus C is to the left. So if C were 4, it'd be left 4. And minus C is to the right. It would be to the right 4. If I put 4 in there, minus 4 will be to the right 4. So if C is outside of parenthesis, it's a vertical shift. If it's inside the parenthesis, it is a horizontal shift, but opposite. Okay. So that's all we have for 2.2. If you have any questions, run back on the videos. I know maybe sometimes I go kind of fast, but you can always watch the videos again. Also, ask Ms. Zara or ask Mr. Hall, me, and we can clear up anything that you may have.